Hello, today we're going to be discussing section 1.3, but let's go ahead and finish up one last topic in 1.2. It's an application. If you look on page 26 of your book, you'll see it says learning curves in airplane production, and they give you the formula that we have here, 150 n raised to the negative 0.322 thousand work hours. Now what this tells you is the number of work hours that it takes to produce the nth plane, okay? So the nth plane. So it says graph this function using your calculator. So let me pull up my calculator here. Oops, let me just adjust this a little bit. Make sure everything is fitting into the screen. Alright. So now you can see I have y equals here, and I typed in 150n. We don't have n, so we'll just use x raised to the negative 0.322. Okay. 1,000 work hours. So now, let me do this so you can see the large screen here. And I want to go to graph. Okay. Now this graph goes from negative 10 to positive 10. It's not going to fit, so I need to adjust it. So let's try zoom fit. Sometimes zoom fit works, sometimes it doesn't. But at least we can kind of see where the graph is and then adjust the window as needed. So we hit enter. Alright, and we see it's somewhere near there. Let's hit trace. So that's when x is 0. And I want my x or n to be 500, right? It says find the time it took to build a 500th plane. So my window needs to go from, let's make it start at 0 because we cannot have negative number of planes, and let's make it go all the way down to 650, okay? And we'll make the x scale go by 100s. Let's see what that does to the graph. I'm guessing because my y min is not low enough, so let's the y min go to 0. Okay. And let's change this to go by 10s. So this you just got to play around a little bit and see. There we go. So we can see that. Okay. Now I want to find the time it takes to build the 500th plane. So that's 20.277, 20.28. So T of 500. Oops. T of 500 is 20.28 thousand work hours, right? So then you can do this. Oops, where's your calculator? And then let me do the other one while I'm here. 600, which is 19.12. And that's 1,000 work hours, right? 1,000 work hours. Okay. So you can do now this second quit, and let's do 20.28 thousand. So you want to multiply this by 1,000. So that's 20,280 work hours. Okay. Similarly, if it was 1,000,000, you could multiply by 1,000,000, 10,000,000, whatever it is. So if you don't know how to do the decimals, then you can multiply. And basically it's the number of zeros, right? If it's 1,000, that's 3 zeros, you move the decimal 3 spaces to the right. 20,280 work hours. I'll just say hours. And this is 19,120 work hours. Okay. So as the construction time continues to decrease, it does more slowly for later planes. This behavior, called diminishing returns, is typical of learning curves, right? So as time goes on, as you build more planes, the construction time continues to decrease, but it does more slowly. That's why we see something like this, right? So even though it's decreasing slower. Okay. Same thing happens with weight loss, right? You start losing weight kind of fast, and then you start losing as you lose more weight, the amount of weight that you lose slows down. Okay. So it's harder to lose that like 20th pound or 25th pound than it is to lose that first pound. Okay. All right, let's go to section 1.3, function. What is a function? A function is simply a relationship. A relationship where for each x, or for each input, okay, and I'll call the input variables x, there exists, for each input there is a unique output. Y. Okay. For each x there exists one unique y. What is the domain? The domain, whoops, is all the input variables. The domain is all the input variables. Okay, all the x values. What is the range? The range is all the output variables. All the y values. Okay. Input set, right? The set of all inputs, and the range is the set of all outputs. The dependent variable is actually, or the independent variable is the x variable, the input variable. Okay, if it's x or t or whatever we have, or n, like we had n above, the dependent variable is the y, which is the output. Okay, or above we had the t, the time it takes to build the nth plane. Okay. Oops, just delete this. Alright. Alright, it says find the domain of the function graphed below. So now you have to look, where are all the, let's look at horizontally, where are all the x values, right? So my domain starts at -infinity, because I start all the way to the left, and you can imagine there are little arrows here, okay? And it stops at 0, right? The x values stop at 0. Remember, for infinity we always put an open parentheses and then 0. Am I including 0 as the value defined when x is 0? Yes. Union. And then where does the x start up again? The x starts up again at 3. Okay. 3, and it goes all the way up to infinity. Okay. And this union stands for OR. Okay, that's the mathematical symbol for OR. So if I said, what is a possible x value? Well, x can be anywhere between -infinity to 0 or 3 to infinity. Let's look at the range, look at the y values. So now what's the smallest y value for this graph? Okay, so is y negative here? No, so the smallest y value we have is 0. Is 0 included? Yes. And then it goes all the way up to infinity. Okay. Let's look at this here. For the function 1 over x minus 1, find f of 5. Well, to find f of 5, all you have to do is plug 5 into the function, 5 in for x, and we get 1/4. Domain. What is the domain? Okay. Well, you think, what x values would make this function undefined? Can you think of any x values that would make this function undefined? Right. Well, in a fraction, 0, you cannot have 0 in the denominator, right? So what would make this function 0 in the denominator? Well, when x is 1. So x, so let me write this. X cannot equal 1, right? So that means the domain is going to be from all the way from negative infinity to 1. Am I including 1? No, I cannot include 1, because 1 would make the denominator 0. Union 1 to infinity. That's saying all numbers except for 1. Oops, I made a little error here. This should be open. Okay. What about the range of this function? Okay, so f of x, or y, if you think there's no way to get this thing to equal 0, right? The only way a fraction can equal 0 is if you have 0 in the numerator, and the numerator will always be 1. So y cannot equal 0. So that means the range is going to be from negative infinity to 0, union 0 to infinity. Okay. Alright, and then you can also graph this on your calculator and check. Okay, let's do that. Y equals 1 divided by x minus 1. And I want to delete everything else. Whoops. X minus 1. And I want to delete everything else. And my window is some weird window, so let me just go to zoom 6, zoom standard. Oops, something happened here, and if that happens, go back. Oh, I have a little error there. Okay, so now I can go to zoom 6. Alright, and you'll see that there's an asymptote at 1, so x cannot equal 1, and there's an asymptote at 0, y cannot equal 0. Okay, let's go on to the next graph here, the next function, g of 27. Okay, well, when you plug 27 into this function, 27 minus 2 gives me 25, square root of 25 is 5, okay? And it's actually, what? Plus or minus 5, right? Let's look at the domain. So, square root. Under the square root, you cannot have negative numbers, right? You cannot take the square root of a negative number. So, z minus 2, whatever is inside the square root, has to be positive. Okay, it has to be greater than or equal to 0. And then we add 2 to both sides. So that means, whoops, just scroll down by accident. So that means z has to be greater than or equal to 2. Okay? So that means the domain is going to start at 2. Am I including 2? Yes, because it can equal to 2. 2 all the way up to infinity. Okay? And then, what about the range? Well, I know what the graph of this looks like. Okay? The graph of a square root looks like this. Right? Kind of like this. And then this minus 2, if it's a minus 2 and the x, that means it's moving to the right 2. So it actually looks like that. Okay? Now, if you don't know what that looks like, that's okay. Just plot it on your calculator. Square root of z, well, we don't have z, we have x. We have to clear first. Square root of x minus 2, and then graph it. Okay, so you can see it starts off at 2 and goes all the way up till infinity for the domain. The range, can this function equal 0? Can the y value equal 0? Yes, when x is 2, y is 0, so the range goes from 0 to infinity. Okay, and this is square root of z minus 2. Okay, so this is function transformations. If you haven't learned them, that's okay. You can use your calculator to graph the function and find the domain and range. Okay. Alright, whoops, what happened? Alright. A graph is a function if and only if it passes the vertical line test. Okay. So you take any vertical line and it must cross the graph at most once. So if it crosses the graph 0 times, then that is okay. Like for example, this function. Is that a function? Well, somebody can argue there's a vertical line there and it doesn't cross the graph. Well, that's okay as long as it crosses the graph at most once. So if it crosses 1 time or 0 times, that's okay. Okay, something like this is not a function. Okay, because I have a vertical line, it crosses the graph somewhere twice. Okay, let's look at this example. An electronics company manufactures pocket calculators, cost of $9 per calculator, and the company's fixed costs amount to $400 a day. Find a function that gives a total cost of producing X calculators. Okay, so first we got to find a function, right? So let the function will be, now it says find a function C. So C is my cost. Okay, that's the Y value to produce X pocket calculator. So that's the X value. So instead of saying Y equals, I want C equals. Okay, C equals what? Well, $9 per calculator, and then the fixed cost is $400, right? And you can make yourself a little table. You can make yourself a little table. Say, all right, 0 calculators. Well, if he doesn't produce any calculators, then he's just paying the fixed cost $400. If he produces 1 calculator a day, that's going to be $400 plus the 9, so that's $409. 2 calculators a day, it's going to be $18. 9 times 2 is 18, and then 400, so 418. And then you can check to see whether your, what you intuitively got from the table matches what you got in the formula. Okay. Now it says graph this cost function. You can graph this on the calculator, okay, or you can graph it by hand. How do we graph by hand? Well, you have to start off with the y-intercept. The y-intercept here is 400. Okay, and we're going to go up 9 over 1, right? The slope, m is 9 over 1. Okay, so that you're going to go up 9 over 1, up 9 over 1, so it's going to look something like this. Okay, that's what my graph is going to look like. And it says, what is the slope telling you? The slope tells you that it's going to cost $9 to produce each extra calculator. Okay, rise over run, rate of change, $9 to produce each extra calculator. So that's what the slope is. The slope is the rate of change, and we call this cost the marginal cost. Okay, let's do another example here. Trucking company will deliver furniture for a charge of $25 plus 5% of the purchase price. Find a function that gives the delivery charge for a piece of furniture that costs X dollars. Okay. So now it says, what is the company's marginal cost? So first thing we're going to do is find a function, right? The delivery charge, D equals, so it's going to charge me $25. So that's my fixed cost, right? No matter how much furniture I get. And then 5% of the purchase price. So 5% is 0.05. of the purchase price is x, because that's the cost of the furniture. Okay, so it's going to be 0.05x plus 25. Okay, what is the company's marginal cost? Well, that is the slope. Okay, so marginal cost is the slope, which is 5% of the purchase price. Okay, and that's not the marginal cost really. That's like the marginal fee, I guess you can say, the marginal profit. Okay. All right, let's go down and let's look at quadratic functions. Okay, so a quadratic function is of the form ax squared plus bx plus c. The graph of a quadratic is a parabola. The parabola opens up if a is positive, right? And the parabola opens down if a is negative. Okay, so parabola opens up if a is positive, and the parabola opens down if a is negative. Now, question is, what happens if a is 0? If a is 0, oops, what happened to the a here? If a is 0, then you don't have a parabola, do you? Because this goes away, this term, and you're left with bx plus c. So when a equals 0, all you really have is just a line. Okay? All you really have is just a not line. So as the coefficient a increases, what happens to the shape of the parabola? Okay? So let's try graphing x squared, 2x squared, 4x squared on your calculator. Okay? And as you graph it, so let me pull up my calculator, y equals, so let's do x squared, and then, I don't know if you know this, you can change the type of line you get here. So let's make that a dark line, let's make y3, we don't want it shaded, that's shading. A dotted line. Okay, so we'll do 4x squared, we'll do 2x squared, okay, and then we graph it. So there's x squared, there's 2x squared, there's 4x squared. So you can see that as you increase the coefficient a, your graph gets narrower. Okay, graph gets narrower, or more narrow, whatever the correct term is, narrower as a increases. What happens to the parabola when a is negative? Well, we saw this. Opens down, and again it will also get narrower. Okay, you can look at that on your calculator. Okay, for a parabola ax squared plus bx plus c, what is the vertex? Okay. Alright, I'm having some, I don't know what's going on with the computer. For some reason it's not recording, but hopefully you saw that. If you want, you can rewind the video and pause it and then get the notes. Okay? So negative b over 2a, comma, f of b over 2a. Okay? So negative b over 2a is going to be the x-coordinate of the vertex. Remember, the vertex is a point. So negative b over 2a is the x-coordinate, and then you take that negative b over 2a and plug it into the y value, or plug it into the original function, f, and then that's the y-coordinate. So let's do this example here. So a, here a is 2, B is 4, C is negative 16. Okay. So negative B over 2A is negative 4 over 2 times 2, which is 4. So that's negative 4 over 4, which is negative 1. Okay, so that is the x-coordinate of the vertex. Now I want to plug in the y-coordinate. So you do f of negative 1. So you're going to plug negative 1 into the original function. So you get negative 1 squared, which is positive 1, times 2 is 2, minus 4 times negative 1 is negative 4, so that's minus 4 minus 16, which is, what is that? 2 minus 4 is negative 2, minus 16 is negative 18. So my vertex is negative 1, comma, negative 18. Okay, that's my vertex. Alright, and then it says the x-intercept. An x-intercept of the parabola is the point at which the graph crosses the what? X-axis. Okay. The x-intercept is where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. Okay. It is also known as a root or a 0. To find the roots, solve f of x equals 0 for x. Okay. So let's look at this one. 2x squared minus 4x equals 6. So first thing you want to do is subtract 6 from both sides to get everything equal to 0. Now, this is 2x squared, sorry. Now let me pull out a 2. So if I pull out a 2, I get x squared minus 2x minus 3 equals 0. Then you're going to divide both sides by 2, divide by 2, divide by 2. Okay. And then you're left with x squared minus 2x minus 3 equals 0. 0 divided by 2 is 0. Okay. Now there's three ways to do this. First way is factoring. Let's see if we can factor this. Let's see, factors of 3 added to give me negative 2, or factors of negative 3 added to give me negative 2. So let's see, if we do x minus 3, x plus 1, right? So I know the factors of 3 added to give me 2 are 3 and 1. And since this is negative here, the larger number has to be negative. Okay, if this was positive here, then the larger number would be positive. Since it's negative, the 3 will be negative, the 1 will be positive, because negative 3 times positive 1 gives me negative 3. Okay, if you're not clear with factoring, go back and review the algebra. And then you set each of these equal to 0. Okay, I'll just do this the first time. You don't have to do every single step here. And then you get x equals positive 3. You add 3 to both sides, x equals negative 1. That is my final answer. Okay, so what does that mean? That means this parabola opens up, right? A is positive, and it crosses the x-axis at 3 and at negative 1, and then wherever the vertex is, we can find it, something like that. Okay, this is just a rough sketch. Okay, it says solve by factoring or graphing. So let's see if we can solve this by factoring. So I'm going to add 30 to both sides, and I'm going to write the negative 3x squared first. So negative 3x squared plus 9x plus 30 equals 0, right? So you got it equaling 0, and then I'm going to pull out a negative 3. So if I factor out a negative 3, I get x squared minus 3x minus 10 equals 0, right? So that gives you negative 3x squared plus 9x plus 30. You divide by negative 3 on both sides, so then the negative 3 goes away. Okay, and then we want to factor this. So x squared minus 3x minus 10. Factors of 10 added to give me negative 3. Well, it's 5 and 2, right? So can I write it as x minus 5, x plus 2? That gives me x squared plus 2x minus 5x is minus 3x minus 10 gives me 0. Okay, so then x equals 5 and x equals negative 2. You think, that was kind of easy, right? So let me check and make sure that this really works out. So then how can you check? Very easily, you can plug the numbers back in. 9, 5 minus 3, 5 squared equals negative 30. So 9 times 5 is 40. Oh, sorry, 45. 8 5s are 40, 9 5s are 45. 5 squared is 25. 25 times 3 is 75. So does 45 minus 75 give me negative 30? Yes, checks out. And then we can also check negative 2. Plug negative 2 into the original function. So this is just the checking part. Okay. And then you plug negative 2. 9 times negative 2 minus 3 times negative 2 squared equals negative 30. So 9 times negative 2 is negative 18. Minus negative 2 squared is, should be squared, negative 2 squared is positive 4 times negative 3 is negative 12. And does that give me negative 30? That works out. Okay. So let's suppose you weren't able to factor or you weren't able to solve by graphing. Then what you could do is use the quadratic formula. Okay. And you can use the quadratic formula anyway. Even if you can factor, you can still use the quadratic formula. Factoring is just easier. So what is the quadratic formula? Negative b, oops, let me make this better. Negative b plus or minus square root of b squared minus 4ac, okay, all over 2a. Okay, so there'll be plenty of instances where we'll be using the quadratic formula in this class. Okay, for right now, I would just like you to memorize it. Alright, let's scroll down. Let's do an example. So as company installs CD players, finds that if it installs X CD players per day, then its cost will be 120X plus 4,800, and that's its revenue. Find the company's break-even points. Okay, let me check the time on the video. Okay, so find the company's break-even points. Okay, so if a company breaks even, that means it's not earning any profit, but it's not making any loss. So the cost will equal the revenue. Okay, so that's what this hint here tells you. Set cost equal to revenue and solve. So I want 120X plus 4,800. So that's the cost. Equal the revenue minus 2x squared plus 400x. Okay, and we want to solve this. Okay, so let me bring everything to one side. So if I add 2x squared to both sides and subtract 400x from both sides, okay, I get 2x squared . 120 minus 400 is minus 280. And then plus 4,800. We set that equal to 0. Okay. Now if I divide everything out by 2, so if I divide by 2, I get x squared. 280 divided by 2 is 140. And then 4800 divided by 2 is 2400. Now, can I factor this? Let me think. 2400 is like, 24 is like 12 times 2, right? But 2400 would be 120 times 2. So 120 times 20, that gives me 2400. And then 120 and 20 also factors to, when you add them up, you get 140. Okay? So then this factors nicely to x. Let's see, I want minus 120 minus 20, because both of these multiplied together have to give me negative, or multiplied they have to give me positive 2400, added they have to give me negative 140, so that works. And then I get x equals positive 120, and I get x equals positive 20. Okay? So if a company breaks even, so first of all, find the company's break-even points. Okay, so X is installs X CD players. So X is the number of CD players. So if they install 20 CD players or 120 CD players, then their profit will equal their loss. I mean, their cost will equal their revenue, so they won't be making any profit. Okay. And then it says here, for the CD installer, find the number of units that maximizes profit and the max profit. Oh, before I go on, if you weren't sure how to factor this, then you could have also used quadratic formula. Okay, so I want you to take a minute, pause the video, do the quadratic formula for this function right here. Okay, and you should also get 120 and 20. Okay? If a company breaks even, how much profit do they make? Profit is revenue minus cost. Find the max profit. So we're going to do, let's do capital P of X, okay, is revenue, which we said was what, minus 2x squared plus 400x minus the cost 120x plus 4800. Okay. And you have to be a little bit careful right here. Let me check this. Yes, the revenue is minus 2x squared. You're not subtracting just the 120x. You're subtracting 120x and also 4800. So you need parentheses around this part, which is the cost. Okay? So then that becomes minus, oops. It's like I'm writing with close to the screen, so if my wrist hits any of the buttons on the keypad, it adjusts messes up the placement. Okay, so minus 20, whoops, minus 2, so let me do this, minus 2, minus 2x squared plus 400x, and then we want to subtract 120x from both sides, or we want to distribute the negative rather, and then minus 4800. Okay, so that is going to be minus 2x squared plus 400 minus 120 gives me what, 280x minus 4800. Okay, and as you can see, that is kind of similar. That is pretty much what I had up here. If you look at this, 2x squared minus 280x plus 4800, right, it's just a negative of this. And it says find the number of units that maximizes profit and the max profit. Okay, so this is a parabola, I know, and it opens down, right, because the a is negative, negative 2 is negative. So I need to find the max profit, or the number of units that maximizes the profit, which means I need to find that vertex. Okay, so we need to do negative b over 2a. That's negative 280 over 2, and a is negative 2, which is negative 280 over negative 4, which is, what, 70? Okay, 7 times 4 is 28, so that is 70. Okay, and then once I plug f of negative b over 2a, I will use my calculator for this, so I don't expect you to do this by hand either. So I want negative 270 squared plus 280 times 70 minus 4800. Okay, and for those of you that have taken my face-to-face classes, you know they're interactive, so I expect you to be doing this on the calculator as well. Okay, rather I have my students do this on the calculator and then provide the answer and confirm. So we get 5,000, okay, and minus, and it's a good idea to check, okay, minus 4,800. All right. So the number of units that maximizes profit is 70 CD players. To get a max profit of $5,000. Okay. When we learn calculus, and we will learn how to do this using calculus, which is faster. Okay, it's a lot less clunky. It's more smooth. It's smoother. Okay, but for right now, we'll just use algebra to do this. Right? And you can see this is the graph that we have here. So you could see that at 20 and 120, the company broke even. Right? So here's the pink line is my cost function. The blue line is the revenue function, and the green line is the profit function. Okay, and when you graph all this, before making 20 CD players, the company is losing money. Okay, between 20 and 120 CD players, they're making money. Okay, and then producing more than 120 CD players, they're also losing money. Okay, and where is the max profit being made? At 70. So you can see that's the apex or the vertex of the profit function. Okay. So that is all of section 1.3. We will continue later, and I will post more videos as the semester progresses. Thank you for watching.